Hello everyone, today we are going to start our exercise 3B maths portion. So before starting with that, there are some properties, so we will first look over that only. The first property is the square of an even number is always an even number. Yes. As we know, suppose we are taking an even number 2, the square root of 2 will always be an even number, that is 4. If we are taking 6 square, it will be 36, which is also an even number. So to be an even number, it must be divisible by 2. Yes. The square of an odd number is always an odd number. Like if we will take 1, this is even. Now suppose 1 square is equal to 1 only, that is odd, right? I will take 9 square is 81, it is not divisible by 2, it means it is odd only. Okay, next, the square of a proper fraction is a proper fraction less than the given fraction. Okay, yes, it is also correct. Means suppose 1 by 3 is there and we are taking out the square of 1 by 3, it is 1 by 9. So 1 by 3 is greater than 1 by 9. How? If we do compare, if we will do comparison, right? 1 by 3, 1 by 9, how we do comparison? 1 into 9, 1 into 3, that is equal to 9, is equal to 3. So which is greater? This is greater. So means 1 by 3 is greater than 1 by 9. Yes. If we take any other number as well, like if we take 1 by 5 as well, 1 by 5, so the square root will be 1 by 25, and 1 by 5 is greater than 1 by 25. Is that clear? 1 by 25, 1 by 20, 1 by 5, 1 by 25, 1 into 25, 1 into 5, 25 is greater than 5. Yes, so that is only written. The square of a proper fraction is a proper fraction less than the given fraction. See, this is a proper fraction. What's a proper fraction? Where the numerator must be smaller than the denominator. So it is a proper fraction. The result is also a proper fraction, but the result is less than the earlier one. Yes, that is the property over here. Next is the square of a decimal fraction less than 1 is smaller than the given decimal. We all know that 2 square is 4 and 2 is smaller than 4, but whenever it comes, it is just a normal number, no decimal, it's normal. If we will take decimal numbers, right, if we will take decimal numbers, so what happens, like 0.1, the 0.1 square, that is 0.01. So 0.1 will be greater than 0.01. If again we will do the comparison, how to do that? The simple is that 0.1, 0.01, it will consist of 2 zeros, it will consist of 1 0. Then what happens? 1 into 100, 1 into 10, that is 100 greater than 10. So obviously it is greater, yes or no? Decimal, always the earlier number in decimal less than 1. Decimal less than 1. If we will write 2.3, right? Sorry, 2.1 also, it will be for 4.41, and 4.41 is greater than 2.1, but it is greater than 1. It should be less than 1, this less than 1, it should be less than 1, then only this rule is applicable. Is that clear? Next is a number ending in 3, 2, 3, 7 or 8 is never a perfect square. Yes, it is never a perfect square, because since we see 1 square, it is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is equal to 49, 8 square is equal to 64, and 9 square is equal to 81, and 10 square to that it is 100. So same pattern will be followed. Is that clear? Same pattern. Okay, see there, 1 4 9, 6 5 6 9 4 1 0. Is there any 2? No. Is there any 3? No. Is there any 7? No. Is there any 8? No. It means a number ending in these digits is never a perfect square. Is never a perfect square. Is that clear? See, 1 square. If I will take any one, 31 square, now the end will be 1 only. If I will take 32 square, the end will be 4 only. 3 square, the end will be 9 only. Like that only. 34 square. Sorry. Okay, if I will take 45 square, the end will be 5 only. And if I will take 76 square, the end will be 6 only. If I will take 77 square, the end will be 9. So there is at the end there is no 2 3 or 2 3 7 and 8. So number ending in these 4 digits is never a perfect square. Is that clear, everyone? Then a number ending in all number of zeros is never a perfect square. Yes, it is true, because if we will take a look that suppose there's a number that is 490. Okay, if you are going to take out the square root, you will see that okay, it is composed of 7 into 7 into 10. There are pair of 7, but there is no pair of 10. So it means a number ending in an odd number of zeros. Like if I take 4 9 triple zeros as well, so 7 into 7 into 10 into 10, then this 10 has no pair. Yes. If I will take 5 digits as well, then also there will be no pair. Exactly. A number ending in an odd number of zeros is never a perfect square. But it doesn't mean the number ending in an even number of zeros is a perfect square. You have to see the number. Like over here, if I will write 4900, it has even number of digits. So you will say yes, ma'am, it has even number of digits. Then it is yes, sir. Since there is an even number of digits, so it is a perfect square. But if I will tell you to do 500, then you will say no, sir. There is no pair of 5. So yes, there is no pair of 5. So it is not a perfect square. Only even number of these numbers doesn't matter. Okay, here it is stated because you have to find out which is not a perfect square. Is that clear? Which is a perfect square, we have to not find out which is not a perfect square. Is that clear? Now there is few patterns over here. Like if I will ask you all to find out the sum of ask you all to find the sum of it. You will add 1 plus 3, 4, then 9, then it was 16. What to do that? You see, how many digits are there? How many numbers are there in total? 1, 2, 3, 4, 5, 6, 7, 8. Yes, there are total 8 numbers. Yes, then what is the square of 8? 64. Answer. Is that clear? If I will tell you this question to find out the sum of it, what is the need to add? How many number of digits? Now, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. 8 square of it, 64 is the answer. Is that clear? No, it is only applicable with odd numbers. Only odd numbers, no even numbers allowed. Only odd numbers. Is that clear, everyone? Like this over here, example has been given. Yes. Okay, so here that is only written in the terms of formula that sum of n odd natural numbers is always n square. Means suppose there are 8, the n is equal to 8, n is equal to 8, then it will be n square is equal to 8 square is 64. Exactly. And one more pattern is there. Here you have to use one formula. What formula you have to use? That a square minus b square is equal to a plus b, a minus b. Is that clear? This formula you have to use, that a square minus b square is equal to a plus b, a minus b. Is that clear? Like if I will ask you the question that let a be 4 square and b be 3 square, what will be the answer? Now you will take out 16 minus 9, that is equal to 7, right? We will do this. No need of doing this. What we can do, a plus b how much? 4 plus 3. A minus b, 4 minus 3. 4 plus 3 is how much? 7. Into 1. Answer is 7. Done. You will say, ma'am, it is much more easier. No, it is easy for now. But if I will give you 31 square, 31 square sorry, 31 square minus 30 square, what you will do? You will find out this, or you will directly do this method. You will do this method only, right? It is 31 plus 30, 31 minus 30, 61 into 1, that is equal to 61. When you're doing the 31 square, okay, how much is 31 square? No need. Directly you can do this method. Is that clear? Yes, no. Okay, next is Pythagorean triplets. Over here there will be three formulas: 2m, m square plus 1, m square minus 1. This you have to remember. Is that clear? So there will be number like one Pythagorean triplet will be given, like 16 is the Pythagorean triplet. When it is given, then you have to take this Pythagorean triplet as 2m, so that you can find out m. How much it is? M is equal to 8. Then m square plus 1, how much? It is 8 square plus 1, that is 64, plus 1, that is 65. Yes. Then m square minus 1, that is 8 square minus 1, that is 64, minus 1, that is 63. Yes, no. Yes, no. Yes. So what are the Pythagorean triplets? Pythagorean triplets, right? Pythagorean triplets is equal to 16, 65 and 63. Why 16? Sir, the answer is 8. No, formula says 2m. The 2m is 16, right? 2m is 16. So in order to find out m, the value of m, therefore we did this. Is that clear? Something else is there. Fifth one, using the identity a plus b whole square is equal to a square plus 2ab plus b square. So suppose the question is given over 53 square. So what happens? You see 50 plus, we can write this 50 plus 3 whole square. Yes, 50 into 50, 525 0. Then multiply this. How much? So what you have to do? 50 square plus 52 multiplied by 50 into, exactly, 50 square, then 50 multiplied by 3 into 2, same thing, 2 into 50 into 3 or 50 into 3 into 2, both will be the same only, plus how much? 3 square, how much? 2 5s are 100, okay, plus 300 plus 9, that is 280. Is that clear, everyone? Yes, one more identity is there, that is a minus b whole square is equal to a square minus 2ab plus b square. Is that clear? A square, suppose I will take it as example is given already, and then 96 square. It can be written as, since we have to use this identity, no plus. Is that clear? So we 90 plus 6 we can, because we have to use a minus b whole square identity. So what we can write? 100 minus 4. Yes, 100 minus 4 is equal to 96 only. Then 100 into 100, then 100 into minus 100 into 4 into 2, then plus 4 square. It is, just by mistake I wrote this 2 square only. 400 is 800, okay, plus 16, that is 100, that is 1 6 at the end, 8 then 2, it will be, wait, will be 1, here it will be 9, do it and here do it 2, 2 1 6 9, 9 2 1 6, 9 2 1 6. Is that clear? Now earlier also I stated one identity, right? This one, same here, same also here we have to use. It is applicable for both the terms. For both the A we can use this. Like question is 49 into 51. Yes, 49 into 51. Okay, leave it. Now for A, A is 49. A square minus B square is equal to A plus B. Okay, it is A plus B. So we will take 50 minus 1. Yes, then over here we will take 50 plus 1. Yes or no? Are you able to understand? 49 to 51. We can write as 50 minus 1. Here we can write as 50 plus 1. Is that clear? That is 50. Both are common, that we can take square. Yes, it is square of it. Then my plus minus minus 1 square. So it will be minus 1. That is 2 4s. 2 4 9 9. 2 4 9. Is that clear? How we used it? 451. 50 minus 1. 50 plus 1. Are you seeing the identity? A suppose 50 we got, B we how much got? 1. The A plus B kitna 50 plus 1, A 50 minus 1. Answer is this. Is that clear? Here you have to main focus on this. This should be equal to this. Is that clear? I will do one more, then you will understand it more clearly. That is 30 into 32. We can write 30 as wait. It is 32 minus 2. Wait, 30 into 32, right? Okay, we can do one thing. That is, we can written as 31 minus 1. Minus 1, then 31 plus 1. Yes, it is known. 31 square minus 1 square, it is 31. How much square? It is 31. 961 minus 1, that is 960 is the answer. Is that clear? Is that clear? Yes. So we will do exercise 3B now only. Give reason that none of the following is a perfect square. Since it ends with a digit 2, therefore it is not a perfect square. Digit 3, digit 7, digit 8 is not a perfect square. Odd number of zeros in next 3. Following are squares of even number. First is the square, because the square of an even number is always an even number. It is written the square of an even number is always an even number, or you can write it is divisible by 2. Second one is not a square of an even number, because the square of an even number is an even number. Clear, the story is done. Third, which are the following are squares of the odd numbers. Second one is the square of the odd number, because the square of an odd number is always an odd number. The last should be odd. That's it. You have to write this only property. The square of an odd number is always an odd number. You have to first pick out. But if it asks reason, you have to give that reason. Without adding, find the sum. Number 4. Number 1. 1 to 21. How many digits? How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 square. How much? 121. Answer. Here 1 to 49. Since we are showing you example 3, exercise 3B, number 4, number 2. 1 plus 3 plus 5 plus 7 till we 2 plus 47 plus 49. Yes or no? So since 1 to 10, there are 5 odd numbers. So 1 to 50 will be how much? 5 into 5, how much? 25 odd numbers. Remember that from 1 to 99, there is 50 odd numbers. So 1 to how much? 1 to 49, how many? 25 odd numbers. Is that clear? So 25, right? What is the answer? 25 square, that is 625 is the answer. And third, you see 1 plus 3 plus 5 plus 7 plus the 99. I said you, right? Third one, 50 square, that is 2500. Is that clear? Now express as the sum of 12 odd numbers. So sometimes it may ask in the question that express 225 as the sum of odd numbers. Now you won't be going to count, so you do one thing. Suppose 225 is the number, okay? Number 2. 225 is the number. To find how many odd numbers you have to use, you can directly use the square root. That is 15. You have to use the square root. So that is 50. So there will be 15 odd numbers. Then you can write 15 odd numbers according to your wish. It is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus you should have 21 plus 23 plus 25 plus 27 plus 29. Is that clear? Now, sixth number, write a Pythagorean triplet. Write the Pythagorean triplet where smallest member is A. Third one, 16, I already gave you the example of it. Yes, I already gave you. Yes, and I think no need of doing. So, I am doing the last one as well. Pythagorean fourth one, 20. So 2m is equal to 20, m is equal to how much? M is equal to 10. Now m square minus 1 is equal to how much? 10 square minus 1, that is 100 minus 1. 99. Then m square plus 1, how much? 10 square plus 1, that is 100 plus 1, that is 109. So Pythagorean triplets are how many? Pythagorean triplets is equal to 2m, m square minus 1 and m square plus 1. So 2m is how much? 2m 20, m square minus 1 99, m square plus 1 101. Is that clear? Next, evaluate. I'm directly doing the last one. Okay, evaluate number 7. Evaluate 108 square minus 107 square. I already told you the formula, that is a square minus b square is equal to a plus b, a minus b. Yes, so you can use this as well. So what is that? 108. It is a square minus b square. Sorry, it is not plus, it is minus sign only. Okay, a plus b. It is a plus b, then a minus b, that is 108 minus 107, that is how much? 15, 1 carry 1 to 15 into 1, that is 215. Is that clear? You have to write this way. Okay, then using the identity, last one I am doing. Using the identity, which identity is there? There is a plus b whole square identity. Okay, a plus b whole square identity. So what can I write? 400 plus 30 square. How much it will be? 400 square plus 2 into 400 into 30 plus 30 square. It is 4 4 16 16. 1,16,000 plus 8 will go 12,024,000 plus 33. This is a 9 up double 0. How much is the answer? Last two digits will be this only. Then 9, then 4, 9, then 4, then answer is 1,84,900. Is that clear? The 9 number I'm doing one from the second one, 192 square. Which identity we have to use? A minus b whole square. So what we can write? 200 minus 8. 2 multiplied by 200 multiplied by 8 plus 8 square. In the formula it is given, you see, plus b whole square, right? Plus b square. Six 200 plus 64. That is, I always said, always add the same what to say, same means positive you should add first. Okay, always. 64 to 8, it will be in 6 3 6 36,864. If any calculation error is there, you can check it out. Okay, sorry for the calculations error. Okay, then 10 number also one only I am doing, that is third one. 94 into 106, again same formula. A square minus b square is equal to a plus b, a minus b, that is 100 minus 6, 100 minus 6, 100 plus 6. It should, then it would be 100 square minus 6 square. 100 square 2 times, from plus minus minus 6 square. How much? That is 64 over here. It will be 1064. Yeah, think so. I hope so. I have not made any calculation error. I hope so. Let me check it out. Oh yeah, 9964. Sorry, 9964. 99. Okay, 99. How much? 9964. Let us do the true false. And for this video we will complete till this only. Then I will start with solve examples of division method. Okay, we have studied about prime factorization. Now we will study for the division method in the next video. A perfect square number always has an even number of digits. A perfect square number always has an even number of digits. True, false, right? 11 number 1. False, because 22 has an even number of digits, but it is not a perfect square. Yes, every number ending in an even number of zeros is a perfect square. I already told you. No, it is false. Why false? I already gave an example of 500. Third, the square of a prime number is prime. Yes, no. Sorry, false. Why? Because 2 is a prime number, but 4 is not a prime number. Yes. Then fourth, there are 10 perfect squares number from 1 to 100.